today's session, we are going to discuss about different types of compressors used in a supercharger and how to regulate the pressure of the air that is entering into the combustion chamber. Right. The idea of going for supercharging or turbocharging is that with the smaller engine, we want to develop more power. Right. With the smaller size engine, we want to develop more power output. Okay. So that is why we are going for this supercharged engine or turbocharged engine. This is achieved by increasing the pressure or by increasing the density of air that is entering. Okay. So when you want to increase the density, then you have to accommodate more quantity of air inside the engine cylinder. As you accommodate more quantity of air inside the engine cylinder, then the pressure is going to increase. And there is a certain limit for this pressure also. Right? If the pressure goes beyond the desirable limit, right? Especially in the case of SI engine, if the intake pressure goes high, then the probability of knocking is higher. Okay, so there is a limit for increasing the pressure also. So if that is the case, then you have to regulate the pressure of the charge or the pressure of the air. Okay, how to regulate this pressure? So these are the topics we are going to discuss today. So let us recollect the supercharging concept. What is supercharging? Supercharging is achieved by driving a compressor by receiving power from the engine itself, right? So a compressor will be driven by the power from the engine, and the compressor will supply high pressure air to the engine for combustion. And in the case of turbocharging, the power required to drive the compressor is going to come from a turbine, which is in turn driven by the exhaust gases from the engine. So this is what we have discussed in the last session. Okay. So turbocharging has both compressor and turbine. This is the turbine part, where the exhaust gases are the products of combustion from the engine, which drives or spins the turbine wheel, and this turbine is mounted on a shaft, and the other end of the shaft a compressor is mounted. So as the turbine spins, this shaft is going to rotate, and on the shaft compressor is mounted, so compressor is also going to spin. When the compressor spins, it is going to take air from the atmosphere and it increases the pressure of air, and the high pressure air is delivered into the engine cylinder for combustion, right? So this we know. So this is a complete schematic diagram representing the turbocharged engine, right? So this is a turbocharged engine. So this is the engine. From the engine, the products of combustion drives the turbine wheel, which is connected to a compressor. So compressor will receive air from the atmosphere, and the compressed air is supplied to the engine cylinder for combustion. Before it is being supplied, as you increase the pressure, its temperature also increases. If the temperature increases, then density decreases. To reduce the temperature, charge air cooler is used, or this is also called as after cooler, right? So in the case of turbo charger concept, we call this after cooler as charge air cooler. Okay. So in the turbocharger or in the supercharger, we employ a compressor, correct, to increase the pressure of the air or the pressure of the charge. Okay. So these compressors are power absorbing turbo machines, right? So turbo machines are nothing but the rotary machines, and there are two different types of rotary machines or turbo machines. One we call it as a power absorbing turbo machine, other one we call it as a power developing turbo machines, right? Turbines are called as power developing turbo machines. Compressors, pumps, these are all called power absorbing turbo machines, because to make the system to run, we have to supply power. Okay. So the compressors are power absorbing turbo machines. Okay. And when we say compressor, we have different types of compressor. We have reciprocating compressor also, but we cannot employ a reciprocating compressor for a supercharger or a turbocharger, right? Because we are going to couple or mount the compressors on a shaft, right? Which the other end of the shaft is connected to a turbine. So when you want to have mount this compressor on a shaft which is connected to the turbine, it should be a rotary compressor, right? So we employ a rotary compressor because rotary compressors are suitable for this turbocharger and superchargers. Okay. So the compressor is driven by the gas turbine, which in turn is driven by the exhaust gases from the engine. This we know. And the compressor and gas turbines are going to be mounted on a single shaft, right? And since these two are connected, and we will be calling this as a single system, the casing for this will be common for both the compressor as well as the turbine in the case of a turbocharger, right? If that is the case, then the products of combustion which is driving the turbine, gas turbine, that should not leak into the compressor part. Okay, so there should be proper sealing has to be established between the compressor and the turbine, right? There should be a clear demarcation between the turbine and the compressor, right? And the possible the compressors coupled to the gas turbine are mostly of centrifugal type. Okay, if you are going to employ a supercharger, assume that you are having a supercharger engine, then the type of compressor can be a centrifugal compressor, or it can be a roots compressor, or it can be a vane compressor. These three are possible, right, in the case of a supercharger engine. Whereas if it is a turbocharger engine, then mostly we prefer only the centrifugal compressor, right? So we have three possible compressors to be used in the case of a supercharger engine. Whereas if it is a turbocharger engine, then mostly we prefer centrifugal compressor, right? So in today's lecture, we are going to discuss about these three types of compressors. So if it is a centrifugal compressor, right, this is very common centrifugal compressor, or centrifugal blowers are also available. You might have come across. So this centrifugal compressor has an impeller, right, or vanes, right? So that we call it as the heart of the centrifugal compressor, right? These are the vanes. Here you can see this is a vane, this is a vane, and this place we call it as a vane passage through which the fluid is going to pass, right? So this is a vane and this is a vane. So here we have multiple vanes, okay, and this complete arrangement is mounted on a shaft, right? So here you can see these are what we call it as the impeller or the vanes, right? The impeller or vanes are going to be mounted in a shroud. Shroud is the base plate on which it is going to be mounted. The impeller blades are going to be mounted. Okay. So the air is going to enter into the compressor axially. It enters axially in the axial direction. The shaft is going to be considered as the axis of the centrifugal compressor, right? So we are having a shaft here, rotary shaft perpendicular to this. So this is the axis of the centrifugal compressor, and the fluid entry is in the axial direction, right? Fluid entry is in the axial direction, and because of the rotation of this impeller, right, the impeller is going to impart energy or angular momentum to the fluid. It is going to impart energy or angular momentum to the fluid. As a result, the pressure of the fluid increases. The pressure of the fluid increases, and it is going to be finally collected in this casing, and it is going to be delivered out with high pressure. Okay, this is the idea of a centrifugal compressor. So the entry is in axial direction, and the fluid takes 90-degree turn as it passes through the vanes of the impeller. Its entry is in axial direction and it passes in the radial direction, means both are at 90-degree. Okay, it enters in axial and leaves radially. Okay, so this is going to have 90-degree turn, and when it comes out, it is going to gain the energy. For any fluid, when it is going to flow through a flow passage, it is going to have pressure energy, right, from your Bernoulli's equation, P by rho g plus V square by 2g plus Z, right? So it is going to have the datum head, it is going to have pressure head, it is going to have kinetic energy, right, V square by 2g, right? All the three are going to be there. And if we are going to allow the fluid to come out with the help of a diffuser, right, here there is a diffuser. So in the case of diffuser, what will happen? Kinetic energy will be converted into pressure energy. Our objective is that to increase the pressure of the fluid. We want to increase the pressure of the fluid. So we are having this diffuser section. So in the case of diffuser section, kinetic energy is going to get converted into pressure energy. So high pressure fluid is going to come out from the centrifugal compressor, right? So this high pressure If it is a CA engine, high pressure air. If it is a SA engine, then it is going to be a high pressure charge that is going to be supplied to the engine for combustion. Okay, so you can have a centrifugal compressor, right? So in the case of centrifugal compressor, as I told you, that the air is going to enter axially and it is going to leave radially, and the centrifugal compressors are also called as mixed flow turbo machines because entry is in axial direction, exit is in the tangential or radial direction, right? It is going to enter axially and it is going to leave radially. So this we call it as a mixed flow turbo machine. And we have axial flow turbo machines also. That means entry will be in the axial direction and exit also will be in the axial direction. Okay. So if you are going to have two different, if the flow direction of the fluid changes as it passes through the turbo machine, then we call it as mixed flow turbo machine. Okay. So the exit pressure of the air is going to be more than the inlet pressure because of the energy that is being imparted by the rotating blades. Okay. The high energy fluid is finally going to be collected in the casing of the compressor. The casing can be either volute casing or it can be a spiral casing, right? Those things you will study once you come to the turbo machines course. Okay. And the blades of the impeller, there are three possibilities are there for the blades of the impeller. It can be either backward curved, radial, or forward curved. Okay. So these are the three possible blades. Depending upon our requirement, we will select the curvature of the blade. Mostly we will go for the backward curved blade, right? Coming to the roots blower, right? In the case of supercharger, I have told you that we can go for either a centrifugal compressor or a roots blower, or we can go for a sliding vane compressor, right? These are the three possibilities. In the case of roots blower compressor, so this is the complete diagram of the roots blower compressor. So this is the inlet passage, flow passage, and you will find one more this side also, right? In this diagram, it is not visible. I will show you a small video. There you can see the inlet port on both the directions, right? And this is the exhaust port or the outlet port. Okay. So the roots blower, this is a positive displacement type compressors, right? Again, the compressors can be defined like a positive type and non-positive type. Centrifugal compressor is not a positive type, positive displacement compressor. Whereas this roots blower compressor, this is a positive displacement type compressor, right? Positive displacement means there will be definitely some output in the outside side, in the outlet side, right? In the exhaust port or in the outlet pipeline or in the discharge pipeline, definitely there will be an output. That is what we call it as a positive displacement type compressor. Okay. See, the roots blower, this has two meshing parts, right? Here you can see, right? This is mounted on one shaft. This is on another shaft, and this we call it as a lobe. Okay. So these two lobes are going to mesh with each other. The lobes will mesh with each other as the compressor operates. When the compressor rotates, these two lobes are going to mesh. And the meshing part, this can be a 2 lobe or you can have 3 lobe also. Here in this diagram you can see this is 1, 2 and 3. There are 3 lobes here, right, in one shaft. And similar to this, you will be having one more. And these two will mesh with each other. Okay. And the space available between the two meshing components will be minimum. So thereby the fluid experiences the transfer of energy from the lobe to the fluid, and thereby its pressure increases, right? So the gap between the lobe are very important for increasing the pressure of the air, right? And it should be minimum. This lobe can be either a straight lobe or it can be twisted. Here we are seeing the twisted lobe. Okay. It can be either a straight lobe or it can be a twisted